All right, today we're going to finish up chapter 11, and all we're going to be doing is turning all those chapter 10 vector properties into three space properties. So you guessed it, we're just going to be adding that third variable. So let's start off by looking up here at our basic properties of vectors. All right, notice these are all the ones that we've learned in our chapters, our chapter 10 sections. We have our vectors u and v. So we have our sum property. We're just adding up the like terms. First terms add together, second terms add together, third terms add together. Our scalar multiplication. All right, if we're doing k times vector u, k distributes to each component of u. Okay, when we're talking about the magnitude of length or length of u with those absolute value bars, okay, that's just our r equation. We're doing our r equation, which is the square root of our component squared and summed up. Remember our dot product, okay? We do use that dot product to find out if things are perpendicular or parallel. All that is multiplying each component, the first and second and third components together, then adding them up. Remember, you'll get one number, okay? You're just going to get a single number from that. 5, the angle theta between u and v. All right, so the angle between two vectors, our cosine theta equals the dot product in u and v over the magnitudes multiplied. So today, it's pretty much just a few examples. So let's go through this. Let's start with example 1. All right, we got two vectors u and v. For a, we're going to be adding u plus 2v. So let's set that up. We have our vector 2, 3, 4 for u, and then adding it to 2 times our v, which is negative 10, 6, negative 2. Okay, that should give you a nice negative 8, 9, 2. Okay, pretty easy stuff. For b, negative v, all we're doing is switching the sign. So switch the signs of the v vector. 5, negative 3, 1. For c, we're taking the dot product of the two. Remember, we're multiplying and adding. Multiply the components, add them all up. Okay, we multiply them all up. You get 10 plus 9 plus negative 4. It's going to give you negative 5. All right, looking at D now. We have u minus v, and we want the magnitude of that result. Okay, so the first thing we have to do is subtract u from v. So u minus v equals 2 minus negative 5, 3 minus 3, 4 minus negative 1. All right, what we get from that is 705. But we're not done yet. From there, we have to find our r. Okay, so that's going to be the square root of 49 plus 0 plus 25. Remember, I squared all those. That's going to give us a square root of 74. All right, we can just stop right there. Okay, just remember all those properties from chapter 10. We're adding a third component to it. So now we're going to look at number 2. Our vectors u and v orthogonal. All right, remember orthogonal is the same thing as perpendicular. All right, so we got to find out if the dot product equals 0. All right, so let's do the dot product. We got 3 times 6 plus 7 times 3 plus 1 times 3. All right, what you get? 18 plus negative 21 plus 3. And that equals 0. So is it orthogonal? Yes, it is, because the dot product equals 0. All right, moving on to 3. Find the value of x so that u and v are orthogonal. So that's the same thing as before, but they're telling us it is equal to 0. So we got to set up our little equation. We're going to have 3 times 4 plus 2 times x plus 6 times negative 3. And we know that it's going to be orthogonal, so it's equal to 0. So now we start solving our equation. You end up with 2x equals 6. So then we end up with an x equals 3. All right? They told us it was orthogonal. We solved for x when the result was 0. Going on down to example 4. Find the measure of an angle theta between u and v. So now we got to do our angle between two vectors formula, our cosine of theta formula, which equals our, well, first let's do our u dot v over here. U dot v is going to equal 2 times 4 plus negative 1 times 3 plus 3 times negative 2. All right, I got negative 1 from that. All right, when we find our u absolute and our v absolute, our magnitude, 2 squared plus negative 1 squared plus 3 squared. This one's going to be 4 squared plus 3 squared plus negative 2 squared. When you get that all up, square them, add them up, get the square root of 14. Okay, because remember we got to do this as well. I got the square root 29. All right, so we plug it all into our equation. We got negative 1 for our dot product, and we're multiplying 14 times 29 square root on the bottom. Just give you negative 1 over 20.15. I just put that in the calculator. So when you do the inverse cosine, theta should equal 92.8 degrees. Okay, remember finding the magnitude, doing the dot product, plugging it into your angle between two vectors. Now looking at 5, all right, a robot arm whose base is at 0, 0, 0 moves an object from U to V. Okay, so we're thinking about a little arm that comes out of the origin and is moving something from point U, or from vector U to vector V. Okay, is the arm more extended at the endpoint of U or V? So we want to find out, is the magnitude, is it more extended, right? The length, what's the length at endpoint U and V? So we want to find the distance from 0 to vector U. And we want to find it the distance from 0 to vector V. Right? So we're just finding the distance from 0 to U. We're finding the distance from 0 to V. Okay, so we start plugging into our distance equations. 23 squared plus negative 41 squared plus 6. Okay, remember these are calculator. I don't expect you to be able to do this stuff on your own. Okay, so what we just found there, we found the distance. So now we're going to do it for V. It's 12. Okay, so the answer is vector U is bigger. All right, vector U has a greater length. So now let's look at B. What is the distance between the starting and ending positions of the arm? So now they're asking, if the arm's out at U and it moves to V, what's the distance that the arm moves? So we're measuring the distance from U to V. So again, our distance formula between 2 points. Okay, continue to simplify. Negative 5 squared plus negative 71 squared. It's 18 squared. 73.4. All right, so we found our final distance. Again, these are all calculator problems. Okay. See now, through what angle did the arm rotate? So now we're doing our angle between two vectors theorem. All right, we're doing our how do we do this? Cosine theta equals our dot product. So let's do our dot first. Dot product U dot V It's going to equal 23 times 28 plus negative 41 times 30. Man, I messed this up. Why did I draw it so far over there? U dot V equals 23 times 28 plus negative 41 times 30 plus 6 times negative 12. Okay. Solve that all out. I got negative 658. Okay, so it's going on top. We already know from our previous, what was that? A, we know from A what our magnitudes are. If you look back up here, remember? Our 42.8 and our 47.4. Already figured those out. Okay, plug it all in. And I got theta equals 109 degrees. Okay, so remember this section, it was all about reviewing our properties from chapter 10 and applying them to 3-space, or adding a third component or a z variable.